Welcome in this movie of driving forces and resisting forces, and this appears to be part of chapter 5 because it's chapter paragraph 5.2 in your book, but we're going to incorporate this in our chapter 2 instead of the paragraph of levers. And so we're going to do the driving forces and the resisting forces, and that has to do when we're going to talk about friction or drag or air friction and rolling friction and Newton's first law that's about driving forces and resisting forces. First of all, what is friction? Friction is what you feel when you're cycling, that force that keeps you down with your speed, and that is on Earth. And on space you do not have friction because you are not rolling on something, you're not sliding on something, and you're also not going through something because simply there is vacuum or nothing in space, at least not that much. So that's very nice because then you can just continue onwards with the same speed. And here on Earth it's different. We go slower. And well, basically if we're talking about friction, then it's the force working against you while moving. In Dutch is het weerstandskracht, and we have drag or air friction. That's because you need to push air aside. That takes effort. So that's a force of the air on you, which slows you down. And you also have rolling friction. That's friction because something is rolling, wheels are rolling, and that's due to deformation of the surface or the wheels. And it's a good idea to try to reduce that. For instance, if you're a cyclist and you want to have less forces working against you, because then you simply can cycle faster. So how can you reduce the drag or air friction when you cycle? Lots of different ways. First of all, you can bend forward so that if you look at you from the front, you are smaller, so that you need to push less wind against you. That is the cross-sectional frontal cross-section. So if the frontal cross-section is reduced, you also have less drag. So that's simply what you do when you bend forward over of your bar. And another way you could reduce the drag is by streamlining yourself, not so that you, for instance, wear a helmet that is better streamlined, or you change the shape of your bike, that the air goes more smooth through around the wheels or the tubes, and that's in drag coefficient or the streamline. So better streamline. Note that a streamline does not automatically has to reduce the frontal cross section. And the streamline is basically the best streamline is that of a water droplet when it goes down, and the worst is that of a brick. The air flows more smooth around the water droplets, so you have less disturbance of the air, and that makes it more easy to go through it. And for the water droplets, and then besides the streamline, there's something else, and that is, for instance, with speed skating. If you take a look at where they go the fastest, at what oval or what ring they go the fastest, and it is on height. That is because the air is less dense over there, so the air density is less over there. So if you reduce one of these three, you basically reduce the friction as well. And last but not least, you can also reduce the air friction by reducing the velocity or the speed. The lower the velocity, the less the air resistance. The rolling friction is not doesn't have to do anything with the basically how fast you go. it is due to the deformation of the surface or the wheels, so we reduce it by having stiffer roads, so not on sand but on tarmac, for instance, or if you make your bikes deform less. Only that's isn't really totally true, because there's also a bit that you go up and down if you are cycling, and that also takes a bit of effort. And sometimes if you don't have a very high air pressure, a little bit less, you're not bouncing that much, you go a bit smoother over the stones and or cobbles, and that makes you go faster or have less rolling friction. But in general, reduce it a bit harder, smoother road surface, and you also reduce it with yes, more pumped up or stiffer wheels, tires, not wheels, tires. That's for instance with trains. They have wheels of iron, and so they deform less than wheels, rubber wheels, so they have less rolling friction. This is what makes you go but drops your velocity, and this is something that has to do with Newton's first law. But Newton's first law, I want to take into account three situations. The first situation is when you speed up. Speeding up is, for instance, if you are standing in front of a stoplight and it goes, because it's red, and it goes green. The other one, if you have a uniform motion, a uniform motion is a constant velocity, a constant speed. That's when you're cycling with the same velocity, and then slowing down. That's, for instance, if you go through the stop sign and you see it is red. Okay, and I first want to say something about the forward force. So force forward, and about the backward force, F backwards, or resisting force. It's called resisting force. If you speed up, then the forward force is there, you're pushing on the pedal, and the resisting force is not there yet. That means that the forward force is greater. If we slow down, then the forward force, well, basically what you do if you slow down, you stop pedaling, so the forward force becomes 0, and the resisting force is still there because you're still moving, or you're even braking. You have a bigger resisting force, a larger resisting force, and that means that now the forward force is smaller. So what does it has to mean then for if you have a uniform motion? Then apparently with a uniform motion, the forward force is not greater nor smaller. That means it has to be equal. And if it is equal to the resisting force, well, that has something to say about the resultant. So the resultant is the forward minus the backward force, so the forward minus resisting force. If the forward force is greater, then it's greater than 0. And if they are equal, now you subtract two equal ones in opposite direction, then it is equal to 0. And of course they're newtons, but wait, 0 is 0. And if you're slowing down, if the resisting force is greater than the resultant is smaller than 0, or it is backwards. And this basically, this one, that if you have a uniform motion that the resultant force is 0, that is Newton's first law. And basically Newton's first law And there are three laws of motion. So Newton's first law of motion is that if there is a uniform motion in a straight line, the resultant force is 0 Newton, and also in backwards, and the other way around as well. So if the resultant force is 0 Newton, there's a uniform motion in a straight line as well. That is Newton's first law, and we're going to practice with that in class. And I'll see you on Monday. Take care.